I present Joshua Castro. Joshua is a young entrepreneur born in Carolina, Puerto Rico. In 2018, he founded Instarz, a startup company focused on the development of habitats for hostile environments. Alongside Roberto Rodriguez, he started he started their plans of developing Remnant, a compact yet expandable lunar habitat that can house up to 6 people. And he's here to discuss the project and present it to us today. So go ahead and take it away, Joshua. Welcome.
Well, today we'll be presenting our lunar habitat remnant. Instarz has been working on this habitat for quite some time now. We are gonna present to you some fairly new updates that we've been working on for the past year. So we were founded in January 2018. We were founded by a group of young students at the University of Puerto Rico at Mayagüez. When we first started, we were around 5 to 6 people, and now there's around 50 to 60 people working on the project. As I said, we're located at Mayagüez, Puerto Rico. This is a reason for that. First of all, we're from Puerto Rico, but Puerto Rico, there's a lot of incentive for manufacturing and especially space companies. So this can help us lower down the cost of operations. So Puerto Rico is a great place to set up this space startup. We design and manufacture self-sustainable space habitats. And we were the first company in Latin America to develop this type of technology. Here's a render of a future headquarters that we're working on right now. One of our goals is to have our headquarters provide us some kind of revenue. So we're trying to establish a food court, maybe some sort of incubator for other startups. Because we know that one of the main problems for space and especially space startups, getting off the ground, looking for other ventures outside of space technology, especially in this market that we're working, space habitat that is still yet underdeveloped. We are looking for various ways and various alternatives to generate revenue for our company. We're working directly. Our goals are set with the Artemis mission. Our first as Remnant will be for the moon, and then we want to set the foundation for eventually having habitats for Mars. We want to establish a sustainable presence on the moon, and we are looking for partnerships, international and commercial as well. We're focusing just on the structure itself of the habitat. As I said before, Remnant is a sustainable base, so we're looking for companies that can help us in that side of the project, especially on the space life support system itself. As you know, Artemis, the moon mission for Artemis is to return by 2024 and to establish a lunar surface deployment by 2028. Our requirements and challenges are that we have to do this habitat low cost. So we're taking in over decades. We're looking at materials that are already on the space sector. We're not trying to be as innovative on the technology itself, but yes, our innovation is within the integration of all of this technology that has been working on for the past 30 years. It has to be lightweight, has to be also safe and reliable. So we're conducting a lot of risk assessment, mission assurance. We're taking in experts from different industries, from NASA itself, to help us establish our credibility within the industry and taking other markets as well to innovate and iterate the design itself before sending it to the moon. It's a self-deployable structure, which means that it does not require any effort outside of the habitat itself, so it will be completely automatic. It can optimize its habitat volume, so when we launch it in the rocket itself and it arrives at the lunar surface, it can expand almost 10 times its size. It's going to be self-sustainable and reusable. So this means that you can take this habitat and move it around. So you can deploy it and then it could be reusable itself for other applications. And it's gonna have the NASA standards for human rating itself for the moon and for here on Earth. One of the challenges that we have obviously is cosmic radiation, the micrometeorite impacts. The cosmic radiation and micrometeorite impacts we're considering using lunar regoliths to set around the dome itself for their habitat, and the use of different materials for these challenges. Low gravity affects the human body itself. Um, it has almost no atmosphere, as we know, and the extreme temperatures. The materials itself and the regolith, as you may know, will help us mitigate this type of challenges. The toxic lunar dust. Currently, we're working on a new type of technology that will help us mitigate this challenge as well, and the physiological and psychological impacts. Here is a render of our lunar habitat. As you may see, there's a hatchet with a module, and there's like a dome figure around the regolith itself. We are considering using solar panels for the first stage of our project. Then we will move to other type of energy sources as helium-3, nuclear power. Here is a photo of the habitat without deploying. Here is how it will land. It has a outriggers for support, and it has some wheels down on the bottom part of the habitat for when it expands. It helps the movement of the habitat, and it does not create some sort of risk for the deployment. It also has a outer ring layer that is the separation mechanism, and it has on the left side a airlock, and on the right side has a docking system. So this habitat can configure itself with other habitat, and it can help create a much larger base. It has the micrometeorite mentioned as well, the outriggers, and here's the deployment process. That is how it will be launched on the Falcon Heavy, the rocket that we are considering. Here is how it will expand. It has like a dome figure. The middle part is an inflatable. And here is how it will look with the regolith upon the habitat itself. Here is some interior layout. It will have 2 floors. Most of the first floor will be for the ECLS systems. It will have a gym, a logistics storage, a maintenance repair, and on the middle, it would have a R&D lab and bathrooms as well. The second floor is for private quarters, the command center, the agriculture area, and on the middle we'll have the common area and a little side kitchen. Here are some of the technical specs. Last year we were considering, for the past 3 years actually, we've been considering having 8 people on the habitat, but since the R&D and some of the feedback that we have received, we've taken down to 4 to 6 astronauts. The first prototype for this, we were considering to be for 12 months, but we're now considering to be on only 3 months maximum. It will weigh around 20 metric tons. It will have a pressurized volume around 625 meters per cubic and a floor area of 200 meters squared. The destination is a lunar south pole, and the life support will be partially closed loop. The key feature of our habitat is that it is expandable as well. Here is a photo of the Falcon Heavy fairing. As you can see, the habitat itself has a 6 meters of altitude and 4.6 meters of length. Here's a photo of the lunar habitat in the Falcon Heavy. And here is some of the space habitat comparison. As you can see, as I said before, our crew capacity is around 6 astronauts. The volume is 625 meters squared. The mass is 20 metric tons. The life support is partially closed loop, and the destination is on the lunar surface. One of our key features is that not many companies working for habitats on the lunar surface. As you can see, most of the companies out there are working for lunar orbit, LEO, but there's not many companies working for the surface as well. Compared to the ISS, our habitat is rather smaller, and it does not weigh as much. The sustainability part, we were considering using the in situ research. So we were trying to extract water from the moon and use the water recovery system as well. For the air, we are considering the OGS system and the CDRA. We're also considering using in situ research for the air. The food, we were considering aeroponics. Why? Because hydroponics can contain a lot of water, and we want to reserve as much water as we can. The energy, as I said before, we were considering solar panels, but eventually we are going to move forward to nuclear energy. And the thermal control systems, we're using MLI to cover the lunar habitat and the lunar regolith as well. Here are some of the Earth applications. This is for more the near future itself. We are first developing this habitat for these type of markets, so then we can move on to a lunar habitat. The design is practically the same, and some of the environments that we're considering has some of the features on the lunar surface, but this will help us to create credibility and generate revenue on a short term. One of the markets that we're considering is the Antarctica research market. Many entities conduct research in this area, and this habitat can be applied for those markets as well. One funny and interesting fact of Instarz is that Instarz was created after Hurricane Maria. The idea came when I went to the States and I visited the Kennedy Space Center, and I studied on one of the most prestigious University of Puerto Rico of engineering, and we were not as developed as I liked it to be on the space sector. Most of the car companies, software companies, environmental companies, but the conversation about space was not happening in my university. So Instarz was created to create awareness of what was happening outside of our university on the space industry. So we wanted to create a company and a project that can help us live on a more sustainable way and help improve or contribute to the space industry. We were like 2 to 3 people on an apartment, and then around 6 to 7 months, our team expanded to 20, 25 people. So we were really grateful for that. So the disaster relief market is a great earthquakes, tornadoes happen, this type of cities, you can use this as shelter. And it can be used also as a military operations base. So the funding process that we're considering for this project, currently we're working with the University of Puerto Rico for an NSF grant. We're looking for an STTR grant uh, with this habitat, but for Earth. We're not considering yet to submit this proposal via the space market. We're just using it for Earth applications first. This will help us create a much larger prototype, uh, conduct the necessary research and analysis that we're still underdeveloped, and then we were going to present it to viability in this type of markets. Then we were considering using private investment to start the production, development, and operations of the company. As I said before, one of our goals at Instarz is to look at different types of revenue that we can generate outside of our product. We want to build a sustainable business plan. We cannot wait to 2028 or 2025 or 2026 to start a contract with some government agency, maybe NASA, and then start generating revenue. We must start generating revenue by 2021, 2022, uh, at most late as possible. And we're going to use this Earth-based technology, as I said, to generate company revenue. And the next step will be the SBIR phase 1. This will be introduced by late August, and the mission concept study that we're working on right now. We're working on an MCR. We have around 60 to 70 people working, proving that the technology and the habitat that we have proposed is the most viable option. We're looking for strategic partnerships, and we're expanding our executive team. We're looking for a CTO, a space architect, and a systems engineer. We are also going to develop a small scale prototype and a VR/AR prototype as well for the interior. We want to have our investors and future clients to interact with the habitat that we are developing. And then we will move to private funds to start. So this is our Facebook page, our Twitter, our Instagram. You can visit our website. On our website, on the Remnant page, you can see a VR of the habitat. You can interact with that habitat, and you can move it around the room. And if you have any questions or concerns, you can email me at joshua.instarz1@gmail.com. Any questions?
Yeah, I've got a question. You may have mentioned it, but I missed it. What keeps the regolith from sliding off the roof?
So we're currently working on we're working on a partnership with a private company that is working on that type of technology itself. There would to keep the regolith as hard as possible.
Okay, I would like to suggest that if you add internal tethers, you could flatten the roof and the regolith could stay on top. But because you got a very high ceiling roof, I believe, in the center of it.
Yeah. We're looking also to have some sort of exoskeleton to maintain the structure itself.
Okay.
Any other questions?
I guess got a question about the limited lifetime of the habitat. It seems like customers, if we can get recurring access to the moon, it seems like customers, whether sovereign clients or private customers, would possibly like to stay there for a pretty extended period of time. Any thoughts on that?
Yeah, we are considering the lifespan of the habitat around 10 to 15 years. But as
Okay.
I said before, this habitat, our goal is to be reusable. So maybe we can take the habitat and reuse it for other purpose as well.
I'm sorry, I thought you said something about 3 or 6 months. Is that stay time, or did I misunderstand that?
You're saying for the long of the mission or the product itself?
I'm not sure. What was it that you were speaking about? I think you said 6 or maybe just 3.
Yeah, the mission for the astronauts and the self-sustainable achievement that we're trying to take is for 3 months for now. Then we will move for 6 months and maybe up to a year. But for the product itself, the habitat itself, the structure, we are looking for a lifespan around 10 to 15 years.
Oh, that's great.
Hi, Joshua. There's one question here in chat. I'll just read it off to you. It's Bigelow Aerospace currently holds the Transhab patent with claims that could possibly bar other types of expandable habitats. This is one factor that has limited commercial interest in the approach. How does that affect your development activities?
Aware of that. What we're trying to do is work with other companies that has some sort of development on this area of the inflatable itself. We will not be able to develop this type of technology because some other companies and other commercial have the patent itself. So we will probably buy the license or maybe create some sort of partnership with them.
To what extent would you be interested in developing just sort of an initial mock-up at rather low cost?
I'm sorry?
To what extent might you be interested in developing your own mock-up just at very low cost, not using the real materials, but just much cheaper materials? You know what mock?
Yeah. So seriously, one sort of approach that we're looking at is using VR and AR. But if we want to build a more physical prototype, we are considering using not the materials itself for the space application as well, but what we're looking at for this year is to develop a mock-up of a VR and an AR technology using technology like HoloLens.
I see. Okay.
Any other questions?
Okay, so I guess without any more questions, let's see, we just had something. Oh, yeah, okay. Yeah, one more quick question in chat. How do you plan on delivering the remnant habitat to the surface of the moon? Yep.
Okay, well, we're not our main focus is on the structure itself, so we're not considering the transportation itself. We will be providing this for our clients that are looking to establish a base, like government entities. But the rocket that we're planning to use is Heavy. It's designed to be used on Falcon Heavy, but as more rockets and the technology improves, it can open a window for our project and maybe have 3 to 4 of these habitats launch on one launch instead of 3 launch as we proposed earlier.
Okay, and another quick question just came in. Would your habitat potentially be able to be deployed in a lava tube or other subsurface void?
So we have considered that possibility. And I believe around 6 to 7 months ago, we are incorporating that into our R&D process. So we're trying to have the habitat be deployed at the surface and on lava tube as well. But as I said before, our main focus right now is to develop these habitats for the Earth applications first to start generating revenue and start iterating the habitat and improving the technology itself.
Hi, Joshua. This is Philip, and I was curious how you guys went from a few people in an apartment to 25 members strong, and with your R&D facility and everything.
So one of our key factors on the human resource is that we have a lot of students from different type of the world and international that apply to our internship program. That is a great way that we have developed the process of this habitat. We have students from United States, from all around Puerto Rico, Germany, Europe that apply to our internship program. And we have mostly students that are graduate students that work a full-time on our internship program. Our internship program does not provide any type of monetary income, but it has the ability to give student credits. But we have constantly around 50 to 70 people working all year round on this habitat. And as I said before, most of these students are graduate students. Some professors have also lended us their hand and have also worked with us on this project.
I really appreciate that this is based in Puerto Rico. And of course, no one can forget September 22nd of 2017 when Hurricane Maria came in. I'm telling you, right here on Earth, something tells me that we're going to need some climate refugee shelters. And that could be, especially if they're hardened and solar powered, able to be independent of a broken grid. I think that would be a fantastic use of some of your configuration. Have you looked into that?
Yeah, we have looked into that. That is one of our main markets that we are addressing, especially here in Puerto Rico, that we are constantly having these hurricanes. Currently, right now, we're having earthquakes mostly every week or so. So Puerto Rico is a great way to develop this R&D process.
I hear, you're looking into the virtual space. Certainly, that is a fantastic way to inspire and help a lot of people encounter and experience. And frankly, maybe you're ahead of the curve the more you dive into this. Of course, eSpace is part of this with the virtual moon. Maybe there's a connection that can be made there. And yet, there's also locations such as in Hawaii that have, or actually very likely there in Puerto Rico as well, there'd be volcanic areas that have lava tubes that you could try. I don't know if there's a mining company you can work with or something to do the drilling, but you can try implementing you know, a real, you know, scaled model, physical model. Have you given that any consideration?
I have not. I think that is a great way, a great thing that we can look into. I don't believe there is any volcano in Puerto Rico or some type of environment like that, but there is some areas in Puerto Rico that can help us, like in rural areas that can help us on the R&D process of this prototype that we're trying to build.
Maybe you need to contact SpaceX and see if they would be able to let you borrow one of those drills for the boring project. And frankly, you know, just with the level of, you know, demonstration, commercial demonstration alone, and then, you know, kind of like, it could be sort of like Biosphere 2. You're familiar with that project out in Arizona? You know, to be able to connect and partner, then you'll find some real amazing acceleration of your implementation. But I think you got to do something physical as soon as you're getting you know, like a theoretically functional virtual space. You know, as soon as you're ready, I would jump into the physical to demonstrate it.
Yeah, I believe that will be one of our key factors. How can this habitat expand itself? How the inflatable can fit on the module itself, and how it will preserve on this type of hostile environments. So yeah, my focus right now is on looking at the analysis part of the habitat and jumping in the most physical part as soon as possible.
Okay, all right. If there's not anything else, then is it okay if the attendees reach out to you on Facebook, Twitter, Instagram, or via email? That's fine for them to reach out?
Yeah, you can reach me out at my personal email is joshua.instarz1@gmail.com, and you can reach us in any of our social platforms.
All right, great. Well, great. Thank you for your presentation today, and we wish you well. All right. Thank you, everyone, for attending, and have a good afternoon.